this lesson, we're going to talk about arithmetic sequences. So first, what's an arithmetic sequence? It's a sequence that differs by the same number every single time. That number is called common difference. So an example, let's say we start at 6 and we're going to add 3. So 6, 9, 12, 15, and so on. That'll be an arithmetic sequence because we're just going to go plus 3 every single time. And that 3 will be known as our common difference. It could also be subtracted as long as it's a constant difference that's added or subtracted every single time, then it's an arithmetic sequence. There's two ways to write an arithmetic sequence. One is called a recursive formula. That means that you're going to use the term before it. So that's what the an minus 1 means. Like this means the term before. For example, if an is a to the 7, this would be a to the 6. So you just get that term and add the common difference, and you get the next term. We can also do it using the arithmetic sequence explicit formula. So that's what this is, and we'll talk more about it. But that lets you find like the 30th term. Instead of having to go one by one, which this formula makes you do, we could just skip to like the 32nd term or the 150th term. That's what the explicit formula lets you do. Okay, little notation from our things here. A1 is the first term. So you see right here, like we have an A1. That's the first term. So on my example here, 6 would be my A1. It's the first term we used. AN's a term number. So like you see AN all the time. You leave it as AN. It's kind of like an X. You're just like, that's a term we're going to find. So sometimes you might see like A10. That means we're looking for the 10th term. So, and then if you see N or T, if they're doing that notation, that's just the actual term. So this is a 10th term. Again, if you see the minus 1, that means the previous term. So like over here, if this was 10, this would be A9. That's the previous term. That's what that means, because 10 minus 1 is 9. And if you see a plus 1, that means the next term. And then common difference is D. So again, important ideas to recap. A recursive formula is very useful to find the next few terms. So if I want to find like the next like 2 or 3 terms, recursive formula is great. An explicit formula is very useful to find the future terms. So I want to find like the 30th term or the 50th term. We're going to use an explicit formula. So first question, is this ordered list 26, 39, 52, 65, 78 an arithmetic sequence? So all we're going to do is find the difference of all of them. So we're going to do like 39 minus 26. That would be 13. Then we're do the same thing with 52 minus 39. That's also 13. 52 to 65, 13. 65 to 78, 13. Since they're all the same, this is an arithmetic sequence with a common difference of 13. So I'll put D equals 13. So I guess I should say yes. The common difference is 13. So this is an arithmetic sequence. How are sequences related to functions? Well, they're honestly kind of the same thing. You can think of sequences as a function where the domain is restricted to the natural numbers and the range is the terms of the sequence. Because in a sequence, we always start with 1, then we go to 2, 3, 4, 5. So that would be our domain of a function. And then whatever we get, the terms of the sequence will be our range. So they really are the same thing, just if we count the natural numbers. If we're going by natural numbers, that's our domain. So like here, f of 1 equals 26 is saying the first term is 26. So like A1 would be 26. And likewise, this would be the second term would be 39. And so on and so on, right? The fifth term will be 78. And that's how it's written in script notation. So you'll see this right here, right? Subscript notation. So the first term is 26, the same thing as f of 1 equals 26, and likewise. So you have to know how to read it, but that means the exact same thing. Okay. Definition. Recursive in mathematics means to repeat a process over and over again, using the output of each step as the input of the next step. A recursive form relates to each term of a sequence to the previous term. It is composed of an initial value and a rule to generate that sequence. So all it's saying is, right, a recursive formula is like you have to use, you're constantly building on top of each other. You start with the initial value, and then it'll give you some rule, and then from that, you could generate the next terms of the sequence. So here's 2 versions of a recursive formula, right? This is the one we're most used to because we're doing a sequence. So whatever our term is, it's the previous term plus the common difference. And this is the way you write it in function notation. So let's do an example. What is a recursive formula for the height above ground of the nth step of this pyramid? So each step is 26 inches tall. So the first step, since they're all 26 inches tall, the first step would be 26 inches. Right? And then if I want to find the next step, I'm just going to add 26 inches to that step. This is called a recursive function. So like this would be the way you write it, right? Whatever step you're talking about, you're just going to add 26 to it because Again, each step here is 26 inches taller than the other one. So our recursive function is this guy. And if I want to find the first step, well, that is 26. So each step is 26. So my A1 is 26. And the rule is AN equals AN minus 1 plus 26. So that's the rule. Okay. So if whatever term I want, it's going to be the previous term plus 26. I already have A1. So if I want to find A2, I'm just going to plug it into the formula. So A2 will be the previous term, right? You can think about this as like 2 minus 1, which is 1, plus 26. Right, that's our formula for A2, but I know what A1 is. It's 26, they told me. So this is just 26 plus 26, which is 52. So A2 is just 52. What if I want the third step? Well, the formula A3 is just going to be the previous term, which is A2 plus 26, right? That's our formula. Whatever the previous term is, plus 26. So if I want A3, I need A2 plus 26. Well, I know what A2, I just figured it out. A2 is 52. So we're just going to plug that in. And I'm going to get my A3 equals 52 plus 26, which is going to be 78. So that's how recursive function works. It might be a little funky because it's like so easy, but that's really all it is. It's just, I want to find the next term. You add the common difference to the previous term, right? If I wanted A4, that's going to be A3 plus 26, which would be 78 plus 26, and so on and so on. So if I wanted to write a recursive formula for this function here, right? So here's my A1, right? That's the first term. And then what's going on with all these? Look at the pattern. We're subtracting 3 each time. So, right, a recursive formula looks like this. And we need a special rule, like A1 equals something. Like that's how you write a recursive formula. So in this case, our common difference, our D, is negative 3. We're going down 3 each time. So my formula is going to be AN equals AN minus 1 minus 3. But I do need a starting point, and our starting point is 25. So we're going to say A1 equals 25. And that's how I can get this pattern, right? Because it'll be 25 minus 3, which would be 22 for A2, and then minus 3 would be 19, and so on. So that's the starting value. Okay, let's talk about an explicit formula. So it's a different formula. It's a little more involved, but you could do a lot more stuff with it. So this is an explicit formula. Let's talk about what everything does. A1 is the first term, just like before. Right? AN's the term number. The nth term, I should say. N is a term number. So if we're looking for the fifth term, I'll plug 5 into here. So this will be A5, but I'll plug 5 into here. And then D is our common difference. Okay. So an explicit formula describes the pattern of a sequence and can be used to find future terms of a sequence, right? So we're going to use the explicit formula to find, like if I wanted to find the 50th term, I could use the explicit formula very easily to find it. Doing it here would take forever. You have to keep on going until you get to the 50th term. You don't want to do that. So we want to use an explicit formula for that. So let's do an example. The cost of renting a bicycle is given by the table below. How can you represent the rental cost using explicit formula? So you can see it goes 1, 2, 3. So it's an arithmetic pattern, and we're adding common difference every single time. It's always 12. That makes an arithmetic sequence, right? And if I want to do an explicit formula, that is this formula. AN equals A1 plus N minus 1 times D. So to fill out an explicit formula, we need a few things. We need our first term and our common difference. That is it. That's all we're going to need. We're going to need the first term and the common difference. So if we look at our problem here, right, the first term is 26, as I've mentioned right here, and our common difference is 12. So we're going to substitute in 26 for our A1 and 12 for our common difference. So we're going to have AN equals 26 plus N minus 1 times our common difference of 12. Now, that's the formula, but you could look at it, right? It's not very helpful. Let's simplify this. So we're going to distribute our 12 into there. So we're going to get AN is equal to 26 plus 12n minus 12. Then we can add up like terms. So we're going to add this 26 and negative 12. Remember, they're on the same side. We just add them up. So we're going to get a subscript n. Remember, that is a subscript there. We're going to put the 12 in front, 12n, and then 26 minus 12 is going to be 14. So plus 14. So you can write it that way. Or if you want, you could write it with the n in back. Either way is fine. But that is our explicit formula. And then with that explicit formula, we can solve things, right? Now it says, what is the cost of renting a bicycle for 10 days, right? 10 days was an item. I would have to keep on going 6 more times to get to 10 days. But with the explicit formula, we just got to plug it in. So we're going to substitute in 10 for our n. So we're going to get A10, right? That's a temp day, is 12 times 10 plus 14. 12 times 10 is 120 plus 14 is 134. So that'll be the cost to rent it for 10 days, $134. Okay, let's move on. Let's write an explicit formula for this example here, just to give it a practice, right? So again, if we're writing an explicit formula, that is an equals a1 plus n minus 1 times the common difference of d. All we have to do is find out what our a1 is and what our common difference is. Our a1 is the first term, so 27. Our common difference, look what's going on every single time. Looks like we're subtracting 2. Minus 2 minus 2. So we get an equals 27 plus n minus 1 times negative 2. I'm going to put in parentheses so I don't think it's minus 2. It's times negative 2. Again, let's simplify it. Distribute that negative 2 to both of these. So I get 27 minus 2n plus 2. Right? Negative 2 times n is negative 2n. Negative 2 times negative 1 is just 2. Add up like terms. And we get our formula. An equals negative 2n plus 29. And again, with that formula, we could find out, I do have to find out the 17th term. I missed that. So you have to find the 17th term. So, right, and so to keep on doing this 17 times, I can just plug in 17 down there. So the 17th term is going to be negative 2 times 17 plus 29. So that's going to be, what was that? 434, negative 34 plus 29. So that's going to be negative 5. Negative 5 is the 17th term. That's the idea. Okay, let's talk about how arithmetic sequences and functions relate again. So in this example, right, we're given an arithmetic sequence, 1, 3, 5, 7, 9. We want to build a table of values, letting the domestic value be the term number, and then graph it. So keep in mind, this is the sequence. The term number is, that's the first term. This is the second term, third, fourth, and fifth, right? This is A1, A2, A3. So we'll put the term number here. All right, so 1, 2, 3, 4, 5. And then this will be the sequence, or the term value, we can call that. Right, and the term value is just a sequence, so 1, 3, 5, 7, 9. Okay, now they want us to graph it. So keep in mind, these are coordinate points, so it's 1, 1 is our first point, right there. Then we have 2, 3, so 2, 3. That's 3, 3, sorry. 2, 3 is right here. Okay, 3, 5, so here's 3, and I have to go up 5. 4, 7, so 4, 7, and then 5, 9. So like that. All right, so that's the thing. Let's connect our points. Something to that effect. Like that. What is the equation of our line? Next, let's write the equation of the line. So we can do this a couple ways. Y equals mx plus b. It's probably the most straightforward way, right? I gotta find my slope. So a couple ways to do it. You have a graph here, so we can do it that way, right? Pick 2 points, do rise over run. So 1 and 2. You can do it that way. Slope here would be 2 over 1. You can do it just from change of y over change of x, right? Our x's are changing by 1, and our y's are changing by 2. So that would also give us 2 over 1, right? Either way is fine. So our slope here would be 2. Our B, now our grid does not tell us what our y-intercept is. Right? Remember, y-intercept would be x equals 0, which I do not have. So you have a couple of ways to do it. So you could go back and figure out what the 0 term would be, or you could look at your graph. My y-intercept right there is -1. Or if you wanted to, you could do a point slope form, right? My favorite form. Right? Our slope is 2. You pick any point like 1 and 1, and you can do the math. Either way works. Either way gets you the right answer. Right, so our equation reminds me y equals 2x minus 1, like that. Now let's see how that connects to an explicit arithmetic sequence, right? Explicit arithmetic sequence, explicit formula is an equals a1 plus n minus 1 times d, right? And we have to find our first term, which in this case was 1 is our first term. Our common difference, what are we adding every single time? We were adding 2 every single time, right? It went from 1 to 3 to 5 to 7, right? Our first term was 1. We're adding 2 every single time. And let's simplify that. An equals 1 plus n minus 1 times 2. Distribute that 2. So 1 plus 2n minus 2. Add like terms. I get an equals 2n minus 1. And if you look at them, right, they're the same thing, right? Because an arithmetic sequence is just a function where the domain is the natural numbers. So it's the exact same idea. Okay, last little bit. How do you write an explicit formula from a recursive formula? So what if I gave you a recursive formula? I want the explicit formula for it, right? So remember, explicit formula would be an equals a1 plus n minus 1 times d. Now again, when we want to write the explicit formula, all we need is 2 things. We need the first term and the common difference. Now, in this form here, in the recursive form, we have those 2 things. We have the first term, very straightforward. They gave it to us. A1 is 7, done. That's a bad 7. There we go. And then this is our common difference, right? We're going to add 4 every single time. That's our common difference. So we get that. We rewrite it. 7 plus n minus 1 times 4. I'll simplify this real quickly. Add like terms, and I get an equals 4n plus 3. Right, so that's how you go from a recursive formula to an explicit formula. Find your a1, find your d, plug it in. For the sake of time, I'm going to skip that one. Let's do how about if we do the other way around? What if I give an explicit formula I want to write as a recursive formula? Right, well, a recursive formula is just this formula. An equals an minus 1 plus d, and then we have our first term, right? Oops, first term. Right, so all we have to do is find the common difference and the first term, very similar to what we did last time, right? To find those 2 things. So here, what is the first term? I don't know it yet, but I do know the common difference. The common difference is always the slope. That right there is our common difference, 1/2. How do you find the first term? Very simple. You have a formula. Plug in n equals 1. That's the first term. So we have a formula here. We have a1 equals 1 plus 1/2 times 1, which will give me 1 plus 1/2, which is the same thing as 1.5. So that'll be our first term. And there we go. That's all you need to write a recursive formula. You figure out what the common difference is, and you figure out what the first term is, and you have a recursive formula. And that's the idea.